Hello students, welcome back. The question is from GATE 2005 exam. It is for 2 marks. Just read the statement. They are saying in a packet switching network, packets are routed from source to destination along a single path having two intermediate nodes. If the message size is 24 bytes and each packet contains a header of 3 bytes, then the optimum packet size is. Okay. So what kind of packets do we want? Very long packets or very small packets? Actually, we need medium-sized packets. Using very long packets will also increase the total time. Using very small packets will also increase the total time. That is the reason they are asking optimum packet size. Okay. Let us understand this with the help of an example. Suppose this is a very long message. It takes around 1 hour to get transmitted. So source takes 1 hour to transmit this message. That means to put this message on channel, this node requires 1 hour. Similarly, this node also requires 1 hour. This node also requires 1 hour. Okay. So total transmission time is 3 into 1 hour. Just keep this in mind. Why are we not considering the propagation time? The last bit will require some propagation time, right? I am ignoring it because here we are discussing about packet sizes. Changing packet size will not affect the propagation delay. Okay. So propagation delay will be anyway same for every packet size. So that is the reason we are ignoring the propagation time. So just keep in mind that if we send this message as 1 unit, it takes 3 hours. Now suppose I divide this message. So I've created say 4 parts of this message. Packet 1, packet 2, packet 3, packet 4. Now let's see what will happen. Here you can get the benefit from pipelining. See, first packet will be transmitted by the source. So what will be the transmission time? Obviously transmission time will reduce because now packet is very small in size. Its size has reduced to 1 by 4 of the original size. So transmission time will also reduce to 1 by 4 of original time. So it will require only 15 minutes now. Okay. That means in a total of 45 minutes, 15 here, 15 here and 15 here. In total of 45 minutes, first message will reach the destination. But in next 15 minutes, second message will reach. In next 15 minutes, third message will reach or the third packet. In next 15 minutes, fourth message will reach. Okay. So this requires 3 into TT. One transmission time here, one here and one here. But after this, every subsequent packet requires only one transmission time because by that time, the next packet will already be present here. See what I'm trying to say is, let us go slow. What I'm trying to say is, at time is equal to 0, this source starts transmitting the first packet. In 15 minutes, first packet reaches here. Okay. Now in next 15 minutes, it will start transmitting second packet. Second packet reaches here at the end of next 15 minutes. Okay. And first packet will reach here. Okay. Now in next 15 minutes, it will start sending the third packet. At the end of those 15 minutes, third packet will reach here, second packet will reach here, and first packet has already reached the destination. Okay. See what is happening currently. This one will try to send fourth packet. This one will try to send third packet. This one will try to send the second packet. And this one is the destination anyways. Okay. So all of the three nodes are sending data in parallel. So that's the reason we are going to reduce the total time by dividing this message into smaller packets. Okay. That is the reason I am saying that we prefer smaller packets, but don't reduce the packet size to a very small value because smaller packets means total number of packets will increase. So the total overhead will also increase because each packet carries a overhead of 3 bytes. Okay. Now let us see what is the time taken in this case. So In 15 minutes, first packet will reach here. In 30 minutes, it will be here. In 45 minutes, it will be here. So 3 into 15 is 45. First packet requires 45 minutes. But in those 45 minutes only, already second packet has reached here. Okay. Now it requires only additional 15 minutes to reach there. So 15 for this one. Similarly, 15 for this one and 15 for this one. So total is 45 plus 45. That is 1.5 hours. So you can clearly see the difference. If we take a very large packet size, we require more time. By dividing that packet into smaller packets, we require less time. Okay. So now let us see what are the options. I hope you have got the basic idea that why I am saying prefer smaller packets. But don't make the packet size very small. So here we are having a packet of 4 bytes. Out of these 4 bytes, 3 bytes will be for the header. It is mentioned in the question. So what is the useful data contained in these 4 bytes? It is 1 byte only. So to send 24 bytes, we must send 24 packets because each packet only contains 1 byte of useful data. In this case, out of these 6 bytes, 3 bytes will be for header. So only 3 useful bytes are sent. So to send 24 bytes, how many packets must be sent? 8, because each packet can contain 3 useful bytes. Okay. So this is 8. Here how many useful bytes will be there? 7 minus 3, that is 4. So one packet can transfer 4 bytes. How many packets will be required to transfer 24 bytes? It is 6. Here you can see 24 by 6 is 4. Okay. So we require these many packets if these are the packet sizes. Now let us see what will be the overhead. Overhead for this one will be each of these 24 packets will contain 3 bytes of overhead. So 24 into 3. 3 4s are 12. 3 2s are 6 plus 1, 72. So 72 bytes is the overhead. 8 3s are 24 bytes is the overhead. 6 3s are 18 bytes and 12 bytes. You can see overhead is lowest for option D. So it is a possibility that option D might be the answer. This criteria says choose larger packet size. Already we have seen that pipelining says choose smaller packet size. Now let's take both of them into count at the same time. So let us see if this is the packet size, how much is the transmission time? So we have already seen first packet will require 3 into transmission time. 1 TT here, 1 TT here, 1 TT here. Okay. So first packet requires 3 TT. This will be how much? Value of TT is length of the packet divided by bandwidth. So length of the packet is 4 bytes. Say bandwidth is X. Okay, let us fix the bandwidth to X for all of these 4 options. So that means first packet requires this much transmission time. This is 3 4s are 12 divided by X. And how many packets will be left? 23 packets are left. Each of those 23 packets will require only one transmission time. So I'm writing it here. For 23 packets, it will be 23 into TT. This is how much? 23 into L by B. Length of the packet divided by B. That means 4 divided by X. Okay. So this is 92 divided by X. Okay. That means first packet requires 12 by X time. X is the bandwidth. Okay, it is fixed. and remaining 23 packets require this much. What is the total time taken? For option A, the total time is 12 plus 92, that is 104. 104 divided by x. So I'm noting it down here. Okay. It is 104 divided by x, this much time. You can see that this is length of the packet, that means it might be in bits. This is the bandwidth, so it might be in bits per second. So the overall unit will be these many seconds, say. Okay, don't worry about unit too much. Now let us see what will happen in this case. We are sending total 8 packets. First packet requires 3 into tt. Okay, 3 into tt means 6 divided by x. Transmission time is length of packet, that is 6 bytes, divided by bandwidth, which we have assumed to be x. This is for the first packet. Remaining 7 packets will take tt time each. Tt time each means total time will be 7 into tt. Okay, tt is already found out to be 6 by x. That means it is 7 into 6 by x. So how much is this? 6 3s are 18 plus 7 6 are 42 divided by x. So 8 plus 2 is 10, that means 0. 4, 5, 6. So this is 60 divided by x. Okay. So you can see option B requires less time. Option B only requires 60 divided by x seconds. Okay. Now let us talk about option C. Here the packet size is 7 bytes. So what will be the transmission time? tt for option C is 7 divided by x. First packet requires 3 tt. And the remaining 5 packets, okay, total 6 packets are to be sent. First packet requires this much time, remaining 5 packets require tt time each. So it will be 5 into tt. How much is this? 7 3s are 21 divided by x plus 7 5s are 35 divided by x. 5 plus 1 is 6 and 5, 56 divided by x. So total time in this case is 56 divided by x, these many seconds. Okay. Now for option D, packet size is 9 bytes. That means transmission time will be packet size by bandwidth, which is 9 by x. So this value now changes to 9 by x. Okay. First packet requires 3 into transmission time. Remaining 3 packets require transmission time each. That means total time for those 3 packets will be 3 into transmission time only. Okay. So this will become 6 into transmission time. So it is 6 into packet size is 9 divided by bandwidth is x. So this will be 9 6 are 54. 54 divided by x seconds. Okay. Now you can see this criteria says that option D must be the answer because the overall overhead is lowest. Okay. This is the overhead. Yeah, this is the overhead. So overhead is lowest for option D, and the pipelining criteria also says in option D total time taken will be lowest. Here it is 104 by x, 60 by x, 56 and 54. So this one is lowest. Hence, according to both of the options, this one must be the answer. According to both of the criteria, this one must be the answer. Okay.